Right. So we talked about the absolute value function. So we showed that V shape. The vertex should be at 0, 0. The right side should have kind of like a slope of up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And the left side should have a slope of up 1, left 1, up 1, left 1, up 1, left 1. You can kind of get used to that. It's our parent function, right? Our standard for what this group of functions should look like. And we talked about up and down shifts. Those happen after the function, and we can just do what they say. So if it says +4, we went up 4. If it said -2, we went down 2. And then the left and right shifts were inside the function, but those ones lied to us. So if it said +5, it was actually -5. So we went left 5. And if it said -3, that was actually a +3. So we went right 3. But still keeping the shape of the graph the same, right? It's still an absolute value, so it's still that V. I went through and wrote those equations, given certain transformations. Then we did the graphing, again, just kind of focusing on where's the vertex, right? So looking at the shifts and seeing how that's going to move the vertex. And so again, just remembering that's a opposite of that. So it says -2, but it's actually a +2, and we trust that one, so it's +3. So going to 2, 3, and then going up 1, right 1, up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1, up 1. The same thing here. So I was at -1, -4. So we're just plotting that point and then kind of using the slope to figure that out. And this is the one I asked you guys to do on your own. And then from there, we went to the stretches and the compressions. And so just remember that our standard, our parent function looks like this. And so if we multiply it by 2, you notice the graph got narrower. If we multiplied by 3, it got even narrower. If we multiplied by something less than 1, so like a half, the graph appeared to get wider. Something even smaller, the graph gets even wider. And so again, the idea there is that the points are being stretched or compressed in their y coordinate. I don't know if I showed you guys this in particular on Friday or not. If we look at comparable points, like if we look at the value where 2 is, right? And so if I look at on the parent function, and then on 3 times the absolute value of x. So we're looking at the y values, right? So the x value for both of these is 2. So what's happening to the y value? So the y value for here is 2. The y value here is 6. So that means this point is 3 times higher, right, when compared to the x-axis. 3 times higher than this point. Right? This one's at 2. This one's at 6. So yeah, that's where this idea of stretching comes from. The points are now further away from the x-axis than the parent function. Okay? So the y values are being stretched higher. And kind of similar thing happens on the compression. If I look at comparable points, so on the parent function, like if I'm looking over here at, yeah, that's right, my lines were a little bit off. So this one should be up here at 4, 4. Again, 4 should get 4. And then here we see this one's at 4, 1. So the y value is supposed to be 4. Here the y value is only 1. So the y value is being compressed, right? It's closer to the x-axis, right, by a factor of 1/4. It's only a 1/4 the distance that it should be. Okay. Again, this, if you think of the parent function being the standard, this is what it should be. It's only 1/4 of the distance. Right here we can see this one's only half of the distance of what it should be, and that's why the 1/2 times absolute value. And that's why we call them compressions and stretches, even though they look wider, they look narrower. The y value is being affected. Remember, that's all based off of the size of the number, not the sign of the number. Right? Everything here was positive. Right? All these things are positive. So it's just the size of the number we're talking about here. Right? So if a is bigger than 1, then that's going to be a stretch. If a is somewhere between 1 and 0, then that's going to be a compression. Right? So that's what we talked about on Friday. The last thing here on the next page. So we're going to fill out this last page and check and see if you guys have any questions. Okay. So something else that we can do to A is that it can be negative. So when A is negative, that's a reflection over the x-axis. And so what happens is that the y coordinate is being multiplied by -1. So it's kind of tricky to realize is that with all this stuff that's happening here, right, I have all these things over here, they aren't actually changing x, right? It looks like it's all happening to x, right? We're adding 1 to x, and we're 2, or multiplying by 1/2. They're not actually changing the x values, right? We decide what the x value is. We plug in a number that we want to plug in. So that's the x value. It doesn't change, right? If I plug 5 into this, the x value is 5. All of this stuff is changing what happens to the y value. Okay, so if I add 1 here, the y value is going to change. If I subtract 2, the y value is going to change, right? If I multiply by -1/2, the y value is going to change. So oftentimes we kind of it's hard to see that, right? We think that it's all happening to x, but it's actually affecting the output of the problem, not the input. Right? The input doesn't change. We decide what the input is. And then all of this stuff changes the output. Okay? So that's what we're talking about here, that those y values were being compressed. Right? The x values were actually the same here. And same thing here. The x values were the same. The y value was being stretched. Okay? So here is it, right? The y coordinate is being stretched. So it's a little weird kind of thing you got to deal with in your head. Okay? I'm going to change one thing. I want you guys to change this to a minus sign on the second one. And number 9 over here. On 7 and 9, we're going to change those to minuses. All right. Again, this is you guys have done before. It's kind of the opposite of what we did here. All right, we had certain shifts and stuff that we wanted to get, so we created the equation from that. Here we have the equation. We want to talk about what the transformations are going to be. And this is what you guys should be doing here on when it says transformation question mark on these, that you should be writing the description of the transformation. I know I didn't point that out on Friday, what that meant. So on these, you're going to write out the little sentence like we're about to. So what I would do if this is me starting this problem, I'm going to kind of look through it in pieces. Okay? So I'm going to highlight things that I notice that I need to make sure I talk about. Okay? So I see that negative sign. I want to make sure I talk about that negative sign. I see that 1/2. I want to talk about that 1/2. And notice that I'm highlighting them separately from each other. I see that positive 1 there. I wanted to make sure I talk about that. I see this -2 there. I want to make sure I talk about that. Okay? So just noticing what I need to talk about. That's kind of my first step there. And then usually you say something like the graph or the function. Okay? It's kind of usually how you start your sentence. I usually say the graph. And then you can choose whatever tense you want. I don't care if it's future tense, present tense, past tense. So you could say the graph will be, the graph was, the graph is. Okay. I usually say the graph. I usually use a future tense, but so that's just me. Okay. And then I go through and I start talking about what each of those things does. Okay. And so a negative causes a reflection. So just talking about the negative, okay, that causes a reflection of the x-axis. So the graph will be reflected. And then I'm going to talk about the half. And since that's between 0 and 1, that's a compression. So you could say vertically compressed or compressed vertically. And that's where you need to use the language by a factor of. And that's 1/2. So we use that language because A is multiplying the function, right? And so that's what factor means. Factors are things that multiply together. So we want to make sure that we're indicating that this is a multiplication idea.
What's the top bit say? Y coordinate is being... Okay.
multiplied. And then the 1, so that's our inside, that's our left and right shifts. Remember, we don't trust that one. So that says +1, but we're going to remember that it's a left shift. So 1 unit. And then outside after the function, that's our up and down shifts. We do trust that one. And so that says -2, so it's going to be shifted down to this is really like as complex of a problem as we could give you. It has everything in it. That's got a reflection, some sort of compression or stretch. It's got a left or right shift, and it's got a up and down shift. So it's got everything in it. So if that's something you can understand, then you can understand the most complex problems, right? So, or if there's something that's tricky, usually it deals with A. People look at that and say, "Hey, I got a -1/2." Okay? You're really going to be a lot better off if you don't think of this as a -1/2. You think of it as a negative that has its own job, and then you think of it as a 1/2, which has its own job. Okay, so we say it at the same time, -1/2, but it's two separate things. Okay, and the negative and the 1/2, separate them. Okay? We can't compress something vertically by a factor of -1/2. It doesn't happen. The negative has its own job, which is reflecting. The 1/2 has its own job, which is compressing. I'm going to flip to Desmos real quick. I'll show you guys something. All right, so you guys can see our parent function there. So y is the absolute value of x. And so there's that idea, like what's the negative do? Okay. So we see the negative in front reflects the graph over the x-axis. So it just opens down there, right? It's still a v, still the same shape. What's the half do? Right? We saw that on Friday, right? So now we see that the slope of the sides is different. Right? It's rising 1, running 2. Can you guys see this little window here that popped up on my screen? I don't know if you guys see that or not.
Yeah, I can.
Okay. So you can see the slope, right? Rising 1, running 2. Okay? So it's changing the slope of the sides, making the graph appear wider. Right? But what happens if I have a negative and a 1/2? Okay? So now it's being reflected and compressed. Okay? So they're both there in the front, but they work separately from each other. Okay? The negative has its own job, which is to reflect. Okay? We also saw that the graph is supposed to be shifted left 1. So we saw that +1. Right? And so you see how the vertex has now shifted over from 0, 0 to -1, 0. We got a left shift of 1. And we're also supposed to shift it down 2. And so that vertex is shifted left 1 and down 2. And then from there, we just use the slope of the sides to draw the rest. Okay? Going down 1, right 2, down 1, right 2, down 1, right 2. Or I go back to the text and go down 1, left 2, down 1, left 2, down 1, left 2. And this tends to be the hardest part for people to figure out, is that these two things are not working together. They're just completely independent of each other. I can get rid of that and still reflect. Right? I can get rid of the negative and I can still compress it. Okay. Okay. So about 7 here. how would we talk about 7?
It will be reflected over the x-axis by 3.
What makes something reflect, Jacob? What do we need to see in order to know there's a reflection?
Negative. Okay.
So we don't have a negative there, so it can't be a reflection. But what's that 3 doing? So you brought up the 3. What's it going to do?
It'll be like a horizontal line on.
What did a 3 in the front do?
3 over 1, so the slope would be up 3, right 1.
Yes, but that's not what we're talking about right now.
Vertical stretch.
So if the number's bigger than 1, stretch. If the number's less than 1, it's compression. Yeah, they're all positive, and it's all we're talking about right now. Just stretching or compressing. So it could be stretched vertically or compressed vertically stretched. It doesn't really matter which way you say that. And then again, you say by a factor of. Okay.
3.
Yeah. Thanks, sir. All right. What else do we need to talk about, guys? What else is out there? Over, shifted right 2. Okay. You did a good job there catching the sign. Okay, what else? Thank you, Clover. And tie, shifted down 5. All right, shifted down 5. Make sure you change that one. All right. Yeah, I hope I changed that. Remember, told you guys to change that on 7 and 9. All right, so we're going to graph those 2 functions. Okay, so let's notice 8 and 9 are the same thing as 6 and 7. Graphing absolute values is pretty easy because of the shape they are. The first thing you're going to do is you're going to find the vertex. Remember, that's based around that idea that the vertex is supposed to be at 0, 0. But when we take that point and we shift it, we need to pay attention to where it's being shifted to. So just like we saw earlier and we talked about earlier, right, our shifts go around what h and k do. So we can see that our h value is -1, right? It says +1, but we need to make sure we switch that sign. And then our k value is -2. Okay? So that means our vertex is at -1, -2. So -1, -2 being over here. So it's supposed to be at 0, 0, but it's been shifted, so we're moving it. And then we go ahead and label that with a V. And then second is going to use the slope, and I'm going to put that in parentheses. Okay. So this deals with what we talked about on Friday with the slopes of what the graph is supposed to be, right? On the right side, the graph is supposed to have a slope of up one, right one, up one, right one, up one, right one. Okay. And we saw that if we multiplied by 2, it went up 2, right one, up 2, right one, up 2, right one, right? And then if you multiplied by 3, it went up 3, right one. Okay. Or if we multiplied it by a fraction, instead of going up 1, right one, up 1, right one, now goes, multiplying it by 1/2, went up 1, right 2, up 1, right 2, up 1, right 2, or multiplying by 1/4, up 1, right 4, up 1, right 4. So we're treating this essentially like the slope of each side, right? But on the other side, I went up 1, left 4, up 1, 4, up 1, left 2, up 1, left 2. Okay. So I'm looking at this as the slope of this side. And so our slope being 1/2. So what I want to do is -1/2, which means I'm going to go down 1, right 2. Remember, only the top here is negative. So that's down 1, but then still positive 2 on the bottom, right 2. So if I go down 1, right 2, I'd end up here. Do it again, down 1, right 2, end up here, down 1, right 2 here, down 1, right 2 here, down 1, right 2 here. Now on the other side, still -1, so I'm still going down, but instead of going right 2, I'm going left 2. All right, because remember that one was the opposite. So I'm gonna go back to the vertex, go down 1, right 2, or sorry, left 2, down 1, left 2, down 1, left 2, down left 2, down 1, left 2. Does that make sense how I use the slope to do that? Anybody there? Okay. Thanks, Jasmine. Thanks, Clover. So notice that it's the same family of functions, right? This, at its core level, this is still a v, right? It's an upside down, squished v, right? That's been moved, but it's still a v. It's still part of the family of functions, right? Its parent is the absolute value, which is a nice sharp v that points up. It has a nice little 45-degree angle sides, okay? So this is one of its children, okay? Still part of the family, still has that same basic shape, okay? So if you're graphing an absolute value, you better be drawing a v. Whether it's a squished upside down v, it's still a v, okay? So how would we draw this second one? Any more than that, Clover? Right, we should have, a vertex should have 2 coordinates, not just 1. There you go, Clover. There you go, Peyton. Okay. So our vertex.
Why is it negative?
Why is what negative?
5.
Because I changed it.
There's no specific reason.
It didn't work well when it was positive. I just needed to change it because it was, the graph does it. Otherwise, the graph kind of goes off the paper too fast.
Oh. Okay.
So I just needed to move it so you guys could see it better. Yeah, so vertex is at +2, -5. +2, -5, so it's down there. There's our vertex, again, just labeling that, right? It's a really important point. Just kind of giving it a label there. Okay, what's next? Got our vertex. What do we do now? Slope, Peyton saying the slope is 3/1. So what's that mean, Peyton? What do I do? Or Tatum, what do we do? Rise 3/1, up 3 over. And I prefer you guys not say over or run because we lose direction with that, right? Run which way, right? So when you say rise, that's definitely indicating up, up 3, you're saying up 3, right? So let's make sure we're saying up 3, right 1, or up 3, left 1, right? We got to make sure we say both. So yeah. So from your vertex, go up 3, right 1, up 3, right 1, up 3, right 1. And then the other side, you're going to go in, since you have to go left, right? So it's going to be up 3, left. So go back to the vertex, up 3, left 1, up 3, left 1, up 3, left 1. Then use your straight edge, draw that line. Just put arrows at the end of those. So Jacob, you asked about the number 3 earlier, right, on the homework. Do you see how you would do it now?
Yeah.
Okay. I think, so you kind of find that vertex and then use your slope to graph the sides, right? So find the vertex and then use this to help you graph the angles out, or the sides out. But again, no matter what, right, your graph should be a V, right? So here we have a sharper V. This one opens up. Of course, it's been shifted, but it's still a V. Anything about graphing now that we've thrown in the stretching and the reflecting you guys want to talk about?
I know why the -2 turns into a +2, but why does the +5 turn into a -5?
It didn't turn into, Lily. I just changed the problem.
Oh, okay. Okay, never mind.
Yeah. It was up here earlier. Like if you left it as a +5, the graph would start up here. And then like you only get this little tiny piece of a graph because it just shoots off the picture so fast. I just wanted it so you guys could see more picture. That's all it was. All right, last two things. Nope, so I'm going to write the equations again. So this time we have a graph we're going to write the equation from. Okay. So essentially we're doing what we did here. Okay, we're writing the equation. We want something to fit a certain shape. Okay, we have certain data or something like that we're trying to fit, right? And here we have an exact picture we're trying to fit. What's the equation for this picture? So both graphs, there's the parent function, Okay, so there's our parent functions there for comparison's sake. Okay, but we're trying to write the equation for G, right? So for the black one here. You know, how you would start this off, like, and coming like out of nowhere, right? If I just, like, in the month, I said, hey, what's the equation for this? How do you start that, right? And so first thing you have to do is say, what's the parent function, right? So what's the shape of this? Okay, that's a V, right? It's not a U, it's not a squiggle like an S or something like that, which, you know, something else. It's not a sharp exponential curve, okay? So, you know, what's the parent function where you start? So, okay, that's a V. What gives me a V? Oh, absolute value. So just kind of getting back, and of course, all we're talking about is absolute value now, right? So it seems easy. But, you know, this is an absolute value function. But essentially what you're going to do is do the same two steps that we just did. So first step is going to be to find the vertex. Okay, and then the second step, instead of using the slope, because we don't have the slope, we're going to find the slope. Yes, Connor, that's good. So, you know, here's our vertex. We need to find that source. I need you guys to pay attention to the scale of this problem. All right, so here's, oops, -1. All right, here's -3. Here's +1. All right, so just the scale is off. Like, don't count the boxes. Make sure you're counting the actual, like, values. So our vertex is at, sorry, V is at -1. It's at +1, -3. All right, and so that would mean that our H value is 1. Okay? And then our K value is -3. And then as you go to find the slope, you only do that for the right side. Okay? So we're only going to find the slope on the right side. And, you know, if you kind of go back to think about why that is, okay? We looked here, right? We went rows 1 ran 4, rows 1 ran 4, so +1 over +4, right? That was the same thing here. But if we went the other direction, when we went rows 1 left 4, that'd be +1 over -4. Right? We could see that this was always the opposite sign of what it was supposed to be. I don't know why I have a 4 right there. It should not be a 4. Okay, so we don't want to use this because that's the opposite of what it's supposed to be. Okay, so we use the right side, and that'll tell us what number needs to be here. Okay. So as I'm looking at that right side, I need to find 2 points on this, on whatever side, wherever I want them to be, it doesn't matter. Okay, as long as there are 2 good points on that side. You know, usually the vertex is pretty easy because it's right there. So if I use that and then I grab any other point on here, okay, I'm just going to go to here. But it doesn't matter. Okay, so what's my rise? What's my run? Again, watch your scale here because I'm going up 2 boxes, but it's actually only a 1 rise. And then I'm running 2 boxes, but it's still only 1 in distance. Okay, so our slope is a rise of 1, a run of 1, which of course is 1. So because this is an absolute value function, right? So g of x equals absolute value of x minus something, right? And then we're going to plug in our h value. We're going to plug in our k value. We're going to plug in our a value. Those things are going to go there, there, and there, right? So our a was 1. Our h was 1. And our k was -3. Then we would just simplify this down, right? I wouldn't write a 1 here. We don't do that. So that really should just kind of go away. There's no double signs here. It's not x minus -1 or anything like that, so I don't really need to simplify anything here, and this isn't going to change either. Okay? The only thing I'm going to do to make this simpler is just basically get rid of this. So g of x would be equal to the absolute value of x minus 1 minus 3. And I don't need you guys doing this and then rewriting it again. if you can go, find the information and then go straight to this, that's perfect. Okay. I'm just doing that so you guys can see it, but if you can go straight to the answer, it's great. Anything about how I did that you guys have a question about? I'm gonna ask you guys to do that last one on your own. Okay. I want you to try the last one there. Again, remember the absolute value bars. You can use the ones that are right above your enter key on your keyboard. I should try and type that in there. Anybody else got an answer? Only gotten one so far. All right, guys, I know you can do better than this. What's going on? I got 2. Um, Connor, can you walk us through how you got that? What you got?
Sure.
Okay. First.
First I looked at how where it shifted.
Okay.
So
you
I
see?
could see that it shifted over 4 to the right.
Okay.
So I was like +4.
Okay.
And then I looked for how much it shifted up or down, and it shifted up 2 units.
Okay. So you found your vertex.
Yep.
Okay.
Then I just looked at the slope.
All right. What'd you see on the slope?
That it was up to over 1.
It's going up to.
Oh, down 2.
Yeah, so it's going down to the right one. Okay. So what'd you do with that -2?
I just add it to the back, I guess. I don't know.
Where'd that go? That's not what you typed to me. Where'd you put that?
Oh, I put it right after the g of x.
Okay. Okay. What about the 4?
I put the 4 inside of the. Are those parentheses or?
Just a couple bars.
Oh.
Okay.
And I
What's
just
here?
added the +2.
What's here?
Oh, positive sign.
What do we know about H?
Oh, it was going backwards, so it'd be negative.
Yep. Oh, yeah. Okay. Didn't have that on there. I see. Yeah, so that should have been my mistake. You typed a plus. I didn't notice that. Yep. So watch out for that when it lies to you, right? So. Okay. Anything you guys need help with there?